We want to derive F distribution. But when you take a look at F distribution, W1 is a chi-squared. W2 is also a chi-squared. W1 is a chi-square with V1 degree of freedom. W2 is a chi-square with V2 degree of freedom. That is the reason why when you are conducting an ANOVA test, we normally have 2 different degrees of freedom, because they are derived from the ratio of 2 independent chi-square. Okay? But in a T distribution, you only have a single degree of freedom. But in a F distribution, you have 2 degrees of freedom. So this is the origin. So I'm going to show you how we derive this. Okay, so like I said, I'm going to show you how to derive that. This is theory of statistics. Okay, please pay attention. Okay, now we want to focus on the F distribution now. Please pay attention. Just be following me, okay? Just be following me. Ask questions if you get stuck. F, so now we want to derive. Let me write what we want to derive. Okay, F distribution is this. G of F is of V1 over V2 raised to the power V1 over 2 F of V1 over 2 minus 1 divided by B of V1 over 2 V2 over 2 1 plus V1 V2 F raised to the power V1 plus V2 over 2. This is what we want to derive. This is F distribution. We want to derive this guy now. Okay, this is what we want to derive. This F distribution. How do we derive it? Now, we want to get started. We want to get started. This is what we're targeting. That's what we want to derive. Okay? Now, we're told, please pay attention, we are told that F equal W1 divided by V1, W2 divided by V2. Okay, W1 follow a chi-square distribution with V1 degree of freedom. So what is F of W1? So I want to write the chi-square distribution now. Okay, that will be exponential raised to the power W1 over 2. W1 raised to the power V1 over 2 minus 1, gamma V1 over 2, then 2 raised to the power of that, W1 greater than 0. When W1 follow chi-square distribution, this is a chi-square distribution. Now, when W2 follow chi-square with V2 degree of freedom, I'm going to write the same thing except instead of V1, I'm going to put V2. Instead of W1, I'm going to put W2. So F of W2 equal this. Okay. Now, what do you think I've written here? I just wrote a chi-square distribution. W1 follow chi-square. This is the distribution. W2 follow because we have 2 variables here. W1 and W2 are the 2 variables. While V1 and V2 are the degree of freedom. Degree of freedoms are not variables. They are parameters. Okay. Now, the next thing that I actually want to do now the next thing that I actually want to do now is we are given this. We have to create artificial variable. So F equal W1 divided by that, W2. So I can create artificial variable U to be W2, to be the one in the denominator, just W2. So I'm creating that. Now, I need to find the inverses here. I need to find the inverses. Here, there's going to be W2 equal to U, right? Here, I need to solve for W1. Okay? And, if I want to rewrite this, this guy is this, right? Mathematically, which is this, right? So, if I want to find this, W1 equal FV1 W2 over V2. Now, can you see my inverses? So my inverse Oh, sorry. This is going to be U. Okay, because W2 equal to U. Does that make sense? Now, I've expressed W1 in terms of F and U, and I've expressed W2 in terms of F and U. F is here, except that it is raised to power 0. Does that make sense? These are the inverses. If these are the inverses, I need to get the Jacobian. Okay, the Jacobian here is going to be the W1, the F, the W1, the U. The Jacobian here is going to be the W2, the F, the W2, the U. So what is the W? What is the W? The W1, the F. The W1, the F is going to be that guy, V1 U over V2. Okay, the W1, the U is 1. Okay, the W2, the F. The W2, the F. The W2, the F is 0. The W2, the U is 1. So here, my Jacobian is going to be V2 over V2U. This is my the absolute value of Jacobian. Now, after getting the Jacobian, don't forget, I need the product of the original variables. Why do I need a product? Because the W1 and W2 are independent. So we're told from the beginning, W1, W2 are independent. So I'm going to say, since W1 and W2 are independent, okay, the G of W1, W2 is going to be this multiplied by this. So I want to multiply this, the way we always do it. We're going to multiply this out. Now, as I multiply now, I want to simplify. If I multiply this by this, I think half is common, right? Half into W1 plus W2. Okay? When I multiply that, then the other one, W1 raised to power V1 over 2 minus 1, W2 raised to power V2 over 2 minus 1, then divided by gamma V1 over 2, gamma V2 over 2. Then I can combine this and this. I can just have 2, okay, V1 plus V2 divided by 2. So this is the joint of the old variables. Now, what do I want to get now? I want to get the joint of the new variable. What are the new variables? The new variables are the new variables are F and U, right? So G of F and U. Okay, if I want to get G of the joint of the new variable, I'll come here. Wherever I see W1, I plug in this guy. Wherever I see W2, I plug in that guy. Okay, so here, I'm actually going to have this. What is W1 plus W2? What is W1? W1 is that guy. F V1 over V2. Okay, that is the W1. What is W2? U plus U. Then here, F V1 over V2 raised to power V1 divided by 2 minus 1. Then U V2 over 2 minus 1 divided by gamma V1 over 2, gamma V2 over 2, 2 raised to power this. Then multiply by the Jacobian, V1, V2U. Look at what I have. That is the joint of F for FU. If I get the joint FU, okay, I need to simplify that. Then to get the G of F, then I will have to perform an antiderivative with respect to U to integrate out the U. So let's simplify. I want to simplify first. If I don't finish that because of my time, you can finish that. This is going to be your final destination. Okay? Now, let me see what I can do within the next 10 minutes. Let me see what I can do. So the G of FU equal exponential raised to power, something is common. Okay, so I want to see if anything is common. Okay, so I have F of V1, V2. Oh, here, I didn't copy that completely. There's a U here. You see that? W1 is the whole of that. So something is common to both. U, right? I can bring the U out. U over 2 into F V1 over V2 plus 1, right? When I bring that out. And here, F raised to power V1 over 2 minus 1. Okay, then V1 V2 raised to power V over 2 minus 1. Oh, that should be V1. Okay, you know, this and this carrying that. Then here, U and U here. U and this one, V1, V2. This one, which one?
Yes, the second parentheses, inside the second parentheses.
This one?
Should there be another U multiplier?
Let me see, W1. Oh, that's correct. Yes. That should be U here, thank you. Okay, so now I'm going to bring the U out to U. Inside that parenthesis, V1 over V2 minus 1. Okay, this is another U, this is another U. Okay, now I can just combine them. U2, I can just put V2 over 2. Okay, V2 over 2 minus 1 we cancel plus 1 here. So I'm only going to be left with that. Then V1 over V2, V1 over V2, then divided by gamma V1 over 2, gamma V2 over 2, 2 raised to the power V1 plus V2 over 2. Now, if you take a look at this guy and this guy, you can cancel that negative 1 because this is raised to the power 1. This, what you have in the parentheses are the same. So if I want to recombining that, this is going to go away. This is going to go away, and this is going to go away, simplifying. Then now, if you take a look at this, okay, V over 2 minus 1 plus V over 2 divided by that. Now, this is what we have. Now, the next is, what is my G of F? My G of F is G of FU du, okay, from 0 to infinity. Okay, I want to perform an antiderivative on this. Okay, without wasting my time. So I'm actually, I want to consider just this one because these are just constants, right? Okay, the one in the denominator is just constant, right? Okay, so G of F equal 0 to infinity. But before I do that, because I want to integrate with respect to U, anything that is not U is going to come out. So this guy going to come out. Okay, this guy is going to come out. This guy going to come out. I'm only going to be left with e raised to power U over 2 FV1 V2 plus 1 U raised to power V1 over 2 V2 over 2 minus 1 du, and the one here, I can put it outside here, gamma V1 over 2 gamma V2 over 2 2 raised to power that. Now look at where we are now. I can use substitution method again. So I can say let K be U over 2 F V1 V2 plus 1. Okay, if K equal to that, what is the K? The U. The K du is F V1 over V2 plus 1 divided by 2. So what is the U? The U is going to be 2 dk divided by FV1 V2 plus 1. So what is my U equal to? My U equal to K divided by FV1 V2 plus 1. Okay? So if this is what I have right now, I'm going to go back to my G of F. You can see, I told you it's going to go forever, but it's going to be the last bus stop. We did a lot in the theory of statistics, a lot of derivations. And that's why it is called theory of statistics. Okay, now here, I'm actually going to have f v1 over 2 minus 1, v1, v2 raised to power v1 over 2, then gamma v1 over 2, gamma v2 over 2, 2 raised to power that. Okay, so here, I'm going to have exponential raised to power k, because I said let k be that. And instead of u, I'm having 2k, or 2k divided by f v1 v2 plus 1, everything raised to power v1 over 2 plus v2 over 2 minus 1. Okay, now you see that? Then the u, instead of the u, 2 dk divided by f v1 over v2 plus 1. Look at that. So all what I need to do is to simplify this one. If I want to simplify, because I'm doing it with respect to k, so here, okay, you know, I'm actually going to have e raised to power that. I'm going to have 2 raised to power this. Okay, if I have 2 raised to power that, because there's a 1 here, the minus 1 is going to go away. If the minus 1 goes away, this guy will cancel this guy. If you see what I'm doing. Okay, so I just want to go so fast now. Okay, look at what I'm saying. 2 carrying this. This is 2 raised to power 1. That 1 cancel negative 1. I'm going to have 2 raised to power this. That will cancel out this. So what I'm going to be left here is just going to be 0 to infinity, e raised to power that. Okay, k raised to power this, k raised to power this, dk, okay, and this guy raised to power that, this guy raised to power 1, 1 cancel minus 1. So here, I'm actually going to have this, okay, then divided by gamma v1 over 2, gamma v2 over 2, and you know this, by the time you combine with this, I'm going to have f v1 v2 plus 1 raised to power v1 plus v2 over 2, okay? Now, can somebody tell me what gamma is that one? What gamma is that? I want to use a gamma function here.
V1 over 2 plus V2 over 2.
Exactly. So here, I'm going to have f v1 over 2 minus 1, gamma v1 over 2, gamma v2 over 2. Okay, you know, when this one go up, become a negative. So I'm actually going to have v1 over 2 plus 1 raised to power negative, v1 plus v2 over 2, and this one is gamma v1 over 2 plus v2 over 2. If you take a look at that. Now, look at this guy. That is a beta function. So this guy divided by this guy is here. Wait, oh, okay, is here. B of v1 over 2, v2 over 2 is this guy. Is this guy. If you take a look at that. Now I have f v1 over 2 minus 1, you can see. Then this guy here. It's actually here. You know, when it is down, the power will be positive. When it go up, the power will be negative. So I can decide to leave it down here, or when it go up, the power is negative. Down. That's how we derive. Let me tell you this, we did a lot. We do a lot in statistics, particularly in the theory of statistics. That is where we put forward the model. Let me tell you this. Every technique in statistics, every equation, every method in statistics, they do not arrive by accident. We derive them. So the essence of this class is to learn how we derive, you know, those necessary formula or method in statistics. Otherwise, if you don't know how we derive them, you won't be able to know how to correct them. Because the method that we have been using over the years is going to get to a point that the method may not commiserate with reality anymore. But if you know the origin of a method, you can fix that method. This is what I'm saying. I want to produce a phone that will be better than this. Before I can produce a phone that will be better than this, I have to know how they produce this phone first. Because what I want to capitalize upon is their weakness. Does that make sense? So trying to understand their weakness is you need to first understand when they were making this phone, what was the weakness? What was the problem or issue that you can identify? Then that is how you can improve that's how you can improve on the quality of the phone. So the same thing also go with method. Some of you will be wondering, why am I learning all this? You are learning all this because there are situations where this is not appropriate. The formula is not appropriate anymore. Things are changing in real life. We don't want a situation where we're going to use a static approach for dynamic situation. What happens in life is changing by the day. And we normally want a situation where the method that we're actually going to apply will commiserate with reality. We don't normally get things right at times when the state of the model and the state of the data don't agree. They have to agree. So, and that is why we're going to keep on doing research. Let me tell you, do you know that this distribution is, I faulted this distribution when I was doing my PhD because of the fact that Ronald Fisher, 1925, that put forward this, indicated some limitations. And if the limitation will come in form of absorption. That's why when you are dealing with the analysis of variance, they're going to say the population has to be independent. They have to follow normal distribution. Each has to follow normal distribution. There should not be any outlier. If there's outlier, your ANOVA test cannot be trusted, which means if there's outlier in the data set, this guy cannot be trusted. And do you know what I did in my PhD? I reparameterized this guy. I solved 200 equations. I reparameterized this guy, to make sure that, even if there's outlier, this guy is going to be robust. But the way it is now, it is not robust to outlier. You've heard about outlier? Outlier, according to Benkamp in 1982, is when a particular data point is in your data set that is not consistent with the rest. If outlier is present in your data set, it will change the direction of decision. This guy cannot be trusted, and that is why we need to keep on doing research. We can't be tired of doing research. Who knows whether tomorrow you're going to come up with your own model too. That's all what I got for you today. Make sure you also